I want you to picture the most fundamental map we have. Not, a map of the Earth or a subway map. I mean the map of the universe itself, the grid of space and time.
Okay.
For the last 100 years, we've been operating under a very specific set of rules, Einstein's rules.
Hmm.
We accept that this map is, well, flexible.
It's malleable.
Exactly. We accept that if you move fast enough, space literally shrinks and time slows down just to keep one thing constant.
The speed of light.
The speed of light, but for you, the observer. It's the ultimate user-centric view of the cosmos, right? The universe bends and warps to accommodate the traveler's perspective.
It really is. But what if that was a mistake?
A huge mistake. Not a small calculation error, but a fundamental philosophical wrong turn we took over a century ago.
That's the premise here.
It is. Today we are unpacking a source that claims we threw away the terrain, the actual map, to focus entirely on the traveler. We're doing a deep dive into the Zion-Chat paradigms, also called Model B in the text.
This is a heavy one. It's a dense geometric critique that asks us to resurrect a concept that, physics thought it killed off in the 19th century.
The absolute field.
The absolute field.
The ether, right. That's almost a dirty word in physics.
Right. And the source material, beyond Einstein, the Zion-Chat absolute field paradigm, isn't just saying Einstein was wrong, it's arguing that special relativity is basically a patch.
A patch.
A mathematical hack we invented because we forgot how to calculate the geometry of moving objects correctly.
Wow. That is a massive claim. We're talking about undoing the bedrock of modern physics here.
We are.
And to do this, the source takes us through some really specific thought experiments. There are trains, something called dummy photons, and even a psychoanalytic breakdown of why our brains get confused by speed.
It's a mix of geometry and cytology, which is, it's a rare combination.
It is. So let's start with the basics. The source sets up two competitors, Model A and Model B. Model A is the Einstein world we know.
Right.
But what is Model B? What is this absolute field?
So to understand Model B, you have to start with what the source calls the God's eye view.
Okay.
Imagine a camera at coordinates 0, 0, 0. This is a third-party observer who is completely stationary. They see the universe objectively. They aren't moving. They are the bedrock.
The truth camera, the unbiased referee.
Exactly. Now, in Model A, that's Einstein's relativity, there is no preferred truth camera. The laws of physics are subordinate to the observer. If you're on a spaceship, light moves at speed c relative to you.
No matter how fast you're going.
No matter how fast you're going. And this is the part that always breaks people's brains.
Yeah, because if I'm flying at half the speed of light and I shine a flashlight forward, common sense says that light should pull away from me slowly.
Right. Like if I run at 10 miles an hour and throw a ball at 20 miles an hour, the ball is only moving 10 miles an hour faster than me.
That's Newtonian physics. It's intuitive.
It is. But Einstein says, no. Even if you are flying at 99% of light speed, that beam zips away from you at full light speed. And to make that math work, Einstein has to warp time and shrink your spaceship.
He changes the ruler to keep the speed constant.
Precisely. Now, Model B, the Zion-Chat view, just flips this. It says, stop warping the ruler. There is a fixed stage, a Maxwellian electromagnetic field.
And the source compares it to an ocean. I like that visual. Let's stick with that.
Okay, the ocean. So the field is the water. Light is a wave moving through the water.
And my spaceship is a fish.
A fish. A very fast fish swimming through that water. Now, here is the critical distinction. If that fish swims fast and flicks its tail to make a wave, does the wave move faster just because the fish was swimming fast?
No. Once the wave is in the water, it moves at the speed of, water. The fish's speed doesn't get added to the wave.
Boo. That is Model B. Light is released into the field. It moves at speed c relative to the field, not the train.
So, if I'm on that train moving through the field and I shine a light forward, I'm actually chasing it.
You're chasing it. The light is moving at c through the field, and so the gap between you and the light isn't opening up at speed c.
It's opening up slower.
It's slower. It's simple subtraction. If light moves at 100 and you move at 10, the gap grows at 90. It's intuitively satisfying.
It really is.
But here's the rub. Because Einsteinian physics forbids this simple subtraction, it has to invent time dilation to, as the source puts it, cover it up.
Cover it up. Sounds conspiratorial. But They actually try to prove this mathematically. They use a simulation, this dummy photon thing.
Yeah.
I want to walk through this because it feels like the smoking gun of their argument.
It absolutely is the smoking gun. The source sets up a very rigid simulation to strip away all the magic.
Okay.
So imagine a massive track that is exactly 20,001 atoms long.
20,001. That seems oddly specific.
It's just to be precise about the center point. So you have this track, and you have our God's eye view watching from the side. Now, at time t equals 0, every single atom on this track and on a moving train that's on the track emits one dummy photon.
Explain dummy photon. Is that a real physics term, or did the source just make it up?
It's a hypothetical particle for this context. Think of it like a tracer bullet or a marker. The rule in the simulation is these photons travel at speed, c equals 1, and they have a hard lifespan. After exactly 1,000 seconds, they vanish.
Poof.
Gone.
Phew. Got it.
Okay, so it's a freeze frame test. We flash the light, wait 1,000 seconds, and then see where everything landed.
That's it. So let's freeze the simulation at t equals 1,000. First question. Where are the photons that started at the center?
They traveled at speed 1 for time 1,000, so they're at distance 1,000.
Right. That is a fixed fact on the map. The light front is at the 1,000-yard line. Simple enough.
Okay, simple enough. But where is the train? The train was moving. Let's say its velocity is mom. After 1,000 seconds, the train is at distance 1,000 times m.
So if it's going at half the speed of light, it's at the 500-yard line.
Exactly. Light is at 1,000, the train is at 500. Now, here's the aha calculation. If you are sitting on that train and you ask, how far is the light front from me? What's the answer?
Well, geometrically, 1,000 minus 500. It's 500.
Correct. The formula is 1,000 times 1 minus m. It's just geometry. But here is the conflict. Einsteinian physics demands that for you, the observer on the train, the speed of light must be constant.
Meaning, if 1,000 seconds passed on my watch, the light has to be 1,000 units away from me.
It must be. But it's not. We just measured it. The light is physically at the 1,000-yard line, and you're at the 500. The distance is 500.
So what gives?
Well, in the absolute field view, yeah, the gap is physically smaller because you moved. But relativity says that's illegal. The speed of light must be constant for you. So to make that 500 look like 1,000, relativity claims your ruler shrank and your clock slowed down.
So the source is arguing that time dilation isn't a physical phenomenon, that it's a mathematical fudge factor to force the answer to be 1,000 when it's actually 500.
That is the core argument. The source calls it a mathematical atom, not a real physical one. It says we are confusing the map, the math, with the territory, which is the field.
It's weird because that feels so much more logical than time slows down. But if it's that simple, why do we get it wrong? Why does, every physicist on Earth accept the warping?
Well, the source brings in psychoanalysis to explain that.
I saw that in the notes. Jacques Lacan.
Yeah, that's a curveball. Usually you don't see French psychoanalysis in a paper about particle physics, but it's a brilliant framing device. The source uses Lacan's 3 worlds to explain our cognitive bias: the symbolic, the imaginary, and the real.
Okay, break those down for me. How does that apply to looking at a train?
Okay, so first you have the symbolic, that's the math, the coordinates, x, y, z, it's a static map. In the symbolic world, a point is just a point. There's no time delay, it's abstract perfection.
Right, that's the textbook view. E equals mc squared. Clean lines.
Then you have the imaginary. This is how we picture the world in our heads. If I imagine a train passing by, I see the whole train instantly, the engine and the caboose at the same time. My mind assumes infinite light speed.
Oh, like playing a video game. I assume what's on my screen is happening now. I don't think about the lag between the server and my console.
Exactly. We intuit the world as being instant. But then there's the real. And in the Zion-Not-Chat paradigm, the real is the electromagnetic phenomenon itself. And its defining feature is
Still delay.
the lag. The lag. The source uses a great example of a camera eye. Imagine a camera positioned 10 units away from the track at y equals negative 10. When that camera takes a picture of the train right in front of it at x equals 0, it's not seeing the train now. It's seeing light that left the train 10 seconds ago.
Because light isn't instant. It had to cross that gap.
Right. But now, imagine the camera looks down the track to the left at x equals negative 10. The distance from the camera to that point is longer. It's the hypotenuse of a triangle, so it's about 14.1 units.
So the light from that part of the track took over 13 seconds to arrive.
Yes. So when you look at a single photo of the track, the center of the photo is 10 seconds old and the edges are 14 seconds old. You are looking at a mosaic of pasts.
That really changes how you visualize reality. We think we see a snapshot of a single moment, but we're actually seeing a smear of different times stitched together.
And the source argues that Einsteinian relativity ignores this directionality. It treats the observer as the static point 0, where everything is relative to them, ignoring that the observer is also swimming through the field, intercepting these old signals from different angles.
It's like we forgot we're part of the scene. We think we're the director watching the movie, but we're actually an actor on the stage.
That's a perfect analogy. The source says we need to factor in our own motion through the field to understand what we're seeing. If we swim toward incoming waves, we encounter them faster. If we swim away, we encounter them slower. That's not time warping, that's just swimming.
Okay, but I have to play devil's advocate here. This isn't just philosophy. We have tested this stuff. The most famous experiment in history, Michelson-Morley, was designed specifically to find this ether, this field, and it failed.
The famous null result.
Yeah, it seemed to prove there was no field. Why does the source think they were wrong?
This is where the deep dive gets technical and really provocative. The source argues that the Michelson-Morley experiment didn't fail to find the ether. It failed to understand geometry. It claims the experiment was flawed from the drawing board.
Flawed. I mean, it mirrors and lasers. It seems pretty straightforward. You shoot light, it bounces back, you measure it.
Think about the Bradley argument, or aberration. The source compares it to a hunter shooting at a moving duck.
Okay. A duck hunt.
If you are a hunter and a duck is flying across your field of view, you don't aim at the duck.
You aim ahead of it. You lead the target.
You lead the target because by the time the bullet gets there, the duck will have moved. Now imagine the Michelson-Morley apparatus. It's a table with mirrors, but the whole table is on Earth, which is moving through space.
Right.
We are shooting light at a mirror, but in the experiment, the mirrors are fixed at 90 degrees. We don't lead the target.
We miss.
We miss the geometric center. The source argues that because the apparatus is moving, the light doesn't hit the dead center of the target mirror. It drifts. But here's the kicker. Think about the return trek.
The light bouncing back to the detector in the middle.
Yes, the light bounces off the mirror and comes back to the central detector. But while the light was traveling, that central detector moved.
Oh, right. The Earth didn't stop moving just because we turned on a laser.
And the source makes a crucial geometric point here. If the two light beams travel different path lengths, which they must if the device is moving and if the speed of light is constant, they cannot arrive back at that central detector at the exact same instant.
Wait, let me process that. The experiment assumes the two beams meet in the middle to create an interference pattern, but you're saying they don't actually meet.
They don't meet at the focal point the scientists assumed. The source suggests the experiment wasn't measuring no ether, it was measuring a geometric miss. The beams arrive at slightly different times or hit slightly different spots on the Irving detector.
So we interpreted the data assuming the equipment was stationary, but because it was moving, we just misread the results completely.
Precisely. The source uses this image of blue cylinders to visualize it. Imagine a coin on a table. If you track that coin through time, it traces out a long cylinder rising upwards. The vertical height is time.
A world tube. Yeah, I've heard of that. The object extruded through time.
Right. Now, light zips through this block of space-time. When we say light hits the mirror, we mean an intersection between a light beam and this world tube. But if the mirror is moving, its world tube is slanted.
And if we don't account for the slant?
We get the coordinates wrong. We assume the light hit here and now, but it actually hit there and then. The source claims that special relativity is essentially a complex way of correcting for these coordinate errors without admitting that the errors come from our motion through an absolute field.
It's like we're trying to balance a checkbook where the numbers don't add up, so we invent a new currency called time dilation to make the balance zero.
That is a very charitable way to put it. The source is much more blunt. It implies we have confused the symbolic map for the real terrain. We've built a physics based on what the observer sees, the imaginary, rather than what is the absolute field.
So let's zoom out. We have these two models. Model A, Einstein's world, elegant, but it warps space and time. And Model B, the Zionod-Chat world, which keeps space and time fixed, but requires us to accept that we are, swimming through a field. Why does this matter?
Well, because of Occam's razor. Simplicity. The source argues that Model B is actually the simpler explanation. It removes the paradoxes.
Paradox is like the twin paradox,
Yeah.
where one twin goes to space and comes back younger.
Exactly. In Model B, there is no paradox. If you fly away from Earth and come back, you move through the field. Your atoms interacted with the field dynamically. It's a physical process, not a magical time warp. We stop forcing 1,000 times 1 minus m to equal 1,000. We just let it be what it is.
It's basically giving us permission to trust our intuition again,
Yeah.
to trust that distance is distance and time is time.
Yes. But it comes at a cost. We have to give up the idea that we, the observers, are the center of the universe. We have to admit that we are just fish in a very large ocean and the waves don't care about us.
That's a humbling thought. We aren't the reference point. The field is the reference point.
And that shifts everything. It changes how we interpret data from stars, how we understand GPS, all of it. If this paradigm is true, the corrections we make for GPS satellites aren't because time is slowing down up there, but because the signal delay is different due to motion through the field.
It's the difference between the clock broke and it took longer to walk here.
Perfectly said. That's the crux of it.
So where does this leave us? We have a century of physics built on Model A. Model B is knocking on the door saying, hey, you missed a spot? Are we supposed to just toss Einstein out the window?
I don't think it's about tossing him out. It's about context. I think it leaves us with a mandate to question the map. The source isn't asking us to burn the textbooks, but to look at those null results of the past, like Michelson-Morley with fresh eyes.
To ask if we really proved there's no field.
Or did we just fail to detect it because we didn't understand the geometry of a moving observer? It's a call to re-examine the foundations.
To check our premises.
It is, and it brings us back to that first image. The dummy photons dying at distance 1,000. They don't care about the train. They don't care about Einstein. They just travel the terrain. Maybe we should start paying more attention to the terrain.
That is a powerful place to land. It's wild to think that the biggest debate in physics might boil down to whether you think the ocean moves with the fish.
Or whether the fish just thinks it does.
Right. As we wrap up, I want to leave everyone with a final thought to chew on. Einstein's relativity is often presented as the ultimate truth, the operating system of the cosmos. But what if it's actually just a user interface, a really clever, user-friendly interface that simplifies the coding by hiding the messy reality of the hardware underneath?
And the source is asking us to open the terminal and look at the code.
Exactly. What if the time dilation we calculate is just a misunderstanding of how long it takes light to chase a moving object? It's a heavy question. Until the next deep dive, keep questioning the map.
And keep swimming.